All right, so hey everyone, welcome. My name is Bruno. The name of the talk is Upgrading Rails While the Wheels Are Turning. If this manages to work. Yes. So I'm Bruno. I'm a senior software developer here at Onfido. And we're going to have a little bit of a dive into how Onfido's core works and how we are working on upgrading it, the Rails version. So, like every startup, in the beginning there was the monolith, right? We start writing features and we put more stuff onto the same app, and usually shipping, delivering features, signing deals are secondary considerations towards make design and proper data modeling and forward-looking code writing secondary to all of those concerns. And so you end up with usually a big ball of code that is a bit unmanageable, written by different people, managing different concerns and so on. This is a high-level diagram of how stuff works for us here. So we have this big monolith called platform. The core business logic and the shared models and so on, something that perhaps in domain-driven design you'd call a shared kernel, is packed in a gem called core. And we have a number of services, internal API, external API, and so on, a bunch of other services also written in Ruby. And from the internal API, we managed to expose the business logic and the core models to other services written in Ruby, Python, or Elixir for language fit, for performance reasons, or because it's cooler these days. All stuff like that. We do have it as a monolith, but we don't ship it as a monolith. So when we want to ship our API service, we package the API service and core as one unit and we ship it. So we're able to independently deploy and scale all of those services. So why upgrade, right? It should be obvious for everyone, but we're actually running on Rails 3 still. The original version, the 3.0 release, came out in August 2010, and we're running on Ruby 2.2 because newer versions of Rails require newer versions of Ruby, obviously. 2.2 came out Christmas Day 2014. We're using later minor versions, but these are the original releases. So August 2010, that's like Victorian times, if you put it into scale of how the internet works, very long time ago. Our idea, obviously, by doing an upgrade is to go from something like this to something like this, which you might think is only for the cool factor or something like that. But in reality, the Japanese bullet train, in over 50 years of service and over 5 billion people transported, has 0 injuries or deaths or any problems with any trains whatsoever, which is amazing. Our targets for this are to move to Rails 5.2, which was released in March 2018, and to Ruby 2.6. It was released in December 2018. Obviously, Rails 3 and Ruby 2.2 are out of support for a long time now. The essentials for this, if you want to do it at your company, you need to have trust. So the team doing this has to be able to set its own roadmap and so on, because work like this usually is so tied to the complications that arise from your specific code base that trying to set actually milestones and sticking to them will be very difficult. So you need to have some kind of leeway and some trust for the people doing this. Autonomy also. Usually this is done by people that are at a senior level that don't require constant monitoring and so on. In our case, the team that's actually doing this, which is me, I have almost no meetings with my team leader or anything like that. So there's a wide berth for me to be able to organize my work in whatever way I want to. And essentially, company-wide engagement. This can't be done by someone that is just sitting in in a cubicle or in an open space and just doing its own thing, and no one else is actually aware of the effort or contributes in any way. That's really toxic, and it's a surefire way that it won't work. So I've done 2 other big upgrades in the past, but it was for dead codes, dead projects, projects that were sitting somewhere. And it's like, hey, Bruno, we want to reuse this, so please upgrade the code. And it's like, okay, fine. In our case, we have multiple commits per day on multiple systems. Stuff breaks on development, so on, and the work that is ongoing for the upgrade has to account for all that. So daily, sometimes hourly rebases to get the latest code and to adapt to change are a necessity. You can't just work on a branch that you took like a week ago and assume that it's all going to be fine. So yeah, this is one example of a lot of branches that are for internal projects, and they have to be kept up to date and rebased every day. More than once a day, some of these will break because they're no longer mergeable because there's a conflict and so on. So you have to go there and fix it and so on. One of the problems for this, other than the cadence of new commits every day, is that all code is hard, right? So we started off in 2015. Some decisions from the past were done when Onfido wasn't super aware of how background checks could work or should work. So the data model that we committed to in certain instances is kind of like not up to scratch to what we know our business domain to be these days. And sometimes you want to check stuff that someone wrote and ask them, and they're no longer with the company because it was 4 years ago. Or they are, and they have no idea of writing that line of code ever, or like totally. So problems will arise. One example of like fast-paced code in a startup is that, for example, for a cash transaction here, you have a Boolean for if it's pending or not, and you have a string for the state that can also be pending. So sometimes you have to deal with how the code is fighting your efforts to make it better. So what if you want to do this at your own company? So it's vital for you to have a working CI infrastructure. For us, when we started, we were running Jenkins, which most people know, right? Which is showing its age. So we started doing a move to GitLab CI that we're running on now. It's pretty cool. So a full build of our platform used to take around 20-something minutes. Now it can be as slow as 9 if the cluster scaling is set to prioritize platform build. So that actually made all of this really easy because it's way faster to iterate on something that you have fast feedback on. I develop on a Mac, and probably you know Docker for Mac's performance is a bit atrocious. So locally, I do everything on my machine. That probably saves me 10 to 15 seconds per build for some components. But after running like thousands of builds, I probably saved like over a couple of weeks of time by now. So make sure that your local environment replicates your deployment window. And if you have an error locally that you don't have on GitLab CI, that should be a big red flag. So how do I start? So step 1, install a Ruby version manager. Because versions of Rails are tied with newer versions of Ruby, usually you need to have the ability to switch between versions really quickly. I use ASDF VM because it supports like 40 languages. So you learn how to use it for one language, you know how to use it for all of them. For Rails 3, 4, and 5, these are the versions that we're using. Step 2, tweaking the Gemfile and the Dockerfile. So for the Gemfile, there's a little known feature from Bundler, is that if you have the bundle_Gemfile environment variable set to a file name, Bundle will use that file name instead of the default Gemfile. So what I did was I have this Gemfile Rails 3, Gemfile Rails 4, and so on. for the first time that you do it, you just move the gem file to Gemfile Rails 3 and the log file as well, and you copy over the 3.1 to the 4.1, so that when you start on Rails 4, you're exactly on the same spot as Rails 3. This is what you should set the default gem file to, so that if anyone doesn't have the environment variable set properly, the gem file is just going to be a raise statement that will show this. So that means that your environment variable isn't, your local environment isn't ready to use these multiple version ones, and the user gets a proper prompt. Same thing for gem files. So for Docker files, you might think that it requires a bunch of changes and so on, but it's really just changing the gem files that you copy and the base image. The rest is perfectly fine. Step 3, you should comment out everything that you have on the gem file except Rails, and just run bundle. You might think that it would be easier to increment the Rails version and just resolve all the versioning errors and so on, but that is a world of pain. It will be really bad. So what you should do is just bump up the initial Rails dependency and then go gem by gem and just uncomment them and see what works, what doesn't. And you can tell exactly which gem adds which errors and so on. This will probably take a while because we have like hundreds of gems on our code base. But when you do manage to run the bundle on Rails 4 or 5, you run the first build and it's just terrible because everything breaks and there's a lot of breakage between source. Rails tries really hard to maintain source compatibility, but between 3 and 4, it's really bad. I hear that it's less bad between 5 and 6. Between 3 and 4 is really bad. Between 4 and 5 is okay. So fix the build. There's going to be a bunch of issues, so you do it. And then you repeat for all the other components too, so that they're all on Rails 4. For our case, since we package our business logic as a gem, we have to make sure that all of the changes that are done to the base gem are accepted by every other component. That's actually a specific problem to how we package our domain logic, but yeah. Useful things along the way. So usually the approach that we went for specifically was to have guard methods for the version, for the segments of the code that are Rails specific. So there's a monkey patch here on kernel, so it's available for everywhere, where you can just specify that, that if you're, for example, on Rails 4 or 5, it should be factory bots. This should be required for the tests, else factory girl. Same thing for the gem spec file name. So you can do stuff like this. So for example, for Rails 3, you can do a has many with an order statement. Order, the order DSL was actually changed in Rails 4. Order constraints have always, for scopes, have to be always callables, so lambdas, and no more of that DSL thing. And the class name, starting from Rails 5, always has to be a string, so it can be lazy loaded. It could be just a constant on Rails 3. Same thing for eager load and replacing includes, not for all cases, but for the ones that we do. So most of the code has these hot segments that are either used by one version or the other. Testing differences too. So factory girl has been deprecated, replaced by factory bot. What we do is we set this factory gem constant to either one or the other, depending on the version. And on core spec helper, we include the syntax methods for each of them. So when you do create on the spec or build stub, create list, on Rails 4 and 5, it calls the factory bot gem, and for Rails 3, the factory girl one. Luckily, the the code the API is the same between all versions. So our specs are the same for 3, 4, and 5. You may come across some instances of old gems. So for example, we use declarative authorization. The last commit was in 2013. Does not support Rails 4 even, or maybe Rails 4, but with some caveats. These guys at AppFolio took upon them to continue developing it and supporting up to Rails 6, so that's pretty good. For some other gems, you're not so lucky. So symbolize that we use for some attributes to always be read as symbols had the last commit 5 years ago. For this, there was no replacement, but I just wrote a concern that does basically the same thing. So these were the only 2 instances that were bad. So out of 200 or so gems that we use, only 2 of them having an issue was pretty good. I think it speaks a lot about the quality in the Ruby world. We really care about backwards compatibility. Some issues that you might find along the way. So Rails 3 and 4 look up constants differently. There's a different algorithm in place. So for some instances, you will have to have the 2 colons before them because the resolution algorithm for 4 will say that it can't find the constant, and for 3 will be fine. Rails 3 and 4 have some changes on the routing DSL, so how you define routes. They're very minor, so you always have to specify via the method or all for Rails 4. You didn't have to do that for Rails 3. Also, for Rails 3, if you say only show for a route, and you in the spec, you try to generate the URL for index or create or update, it won't give you an error. It will on 4, because it will say that that route should not be generated. So a lot of the changes here are actually Rails 4 being a bit more strict and enforcing more discipline, and Rails 3 just being like, whatever, yeah, do whatever, man. Some gem updates need Ruby 2.3 or up. So for example, devise, we're stuck on the version of devise that we are on now on Rails 3 because the newer versions need a newer version of Ruby. So one more reason to update. Samey tests. So our codebase has a few tests that actually test only the happy path and one other condition and not all of them. So that's a problem when you want to make sure that your code is entirely up to scratch on the new version because your coverage is not that good. So you should try to introduce a bit more variation for stuff like that. For performance reasons, we ran our test suite in parallel. That was hiding a bunch of issues. So by separating the processes by 12, so each process runner was running 1/12 of the tests. There were some times that we had some issues, and our solution was to rerun the build, and they would go away. But if you run them, all of them serially, you realize that there are some issues, and you'll figure them out. So probably there's stuff like a spec that's not doing a cleanup, or a spec that pollutes the environment for all other tests and so on. We cleaned up all of those, and now our specs run serially really quickly. If we do it in parallel, even more so. Specs relying on global state. So if you write a spec that relies on something that other spec created, that's going to be a world of pain. A lot of the time that went into the upgrade was to make sure that the entities that are covered in the specs or that are being tested in a specific spec are created by that spec and not relying on the first employer that's on the database or something like that, because that's not going to work long term. So that was a bit painful as well. And the assets pipeline. So it's a bummer to upgrade it from 3 to 4 and to upgrade it from 4 to 5. So the assets pipeline is kind of like the bastard child for any Rails code base. Is a thing that you think like, yeah, this sometimes works. I may not need this. And that shows in the code because even the rest of Rails is really kept up to scratch in like how your upgrade path should work. From 3 to 4, it was just like, hey, you just have to redo everything for some things. And for 4 to 5, the same thing. Maybe now with Webpacker it's going to be better. Some specific aspects of how we were using the SS pipeline were not supported going forward, so it was a pain. Our current status, so all of our components and our code base for our platform is running 100% on Rails 4, and 15% of it is already on Rails 5. The future, maybe go for Rails 6, since the project will only be concluded in the near future. Maybe by that time we'll already be on Rails 6, and instead of jumping from 3 to 4 to 5, we can just jump from 3 to 6 if we test everything and so on. Key takeaways. So Ruby is very flexible. There's a lot of stuff that you can do, mangling constants and so on, that other languages do not allow you to do and give you enormous flexibility. Enormous flexibility. Old code is hard. This is like the biggest one, right? So that's a lot of code that some people don't really want to be remembered that they wrote or something like that. So when you track people down or when someone leaves and so on, it's really hard to build something that will satisfy the original goals when like the specs are the only documentation and they're kind of samey. So you're stuck between a rock and a hard place when you want to change that code. It's very resistant to change. It's harder for a team of one. So usually the stories that I hear, and I heard one tonight too, that it's one guy doing this. So upgrades are not seen by business as delivering a ton of value. So they don't see a lot of attention. And which kind of explains why most upgrades that you hear of large code base take so long, because it's really taxing. You need frequent breaks because it's a lot to take in without a rubber duck or someone to talk to. It's occasionally lots of fun. So it's pretty cool for you to be able to run hundreds of thousands of lines of codes in a new version, and you did it by yourself, and it all works, and specs pass, and it's faster, and the memory allocation is way better, and all of those things. Company engagement really helps. So whenever I reach out to someone for help, most of the time people are just like, yeah, sure, I'll help you. If I don't know it, I'll find someone who can actually authorize me to get rid of that. Something like that. But most of the time, just having someone to bounce off some ideas really helps. And if nobody cares at your company for it, it's really painful. And yeah, because of the fact that I'm doing this on a live code base that is changed multiple times a day, it is a balancing act that sometimes just makes it just the worst. So yeah, that's it. Any questions?
What does your CI look like? Do you have any? I'm sure there would be ways to help you with constant commits, get something to the CI that like don't allow any deprecation warning.
Yeah, so I don't know if you try to like impose stuff like Rubocop on a group of developers or something, you're gonna have a hard time. What we do now is like we have, once a component is merged into our main code, for example, our builds run the whole of platform, all the components in Rails 3, and the core component and one other in Rails 4. So once it's in, if you break it, the build won't pass. So we make sure most people, when the build breaks on Rails 4, they talk to me because they don't even know or run it locally in Rails 4. And when it does, it's usually pretty simple because most of the big issues were already solved by me and they were merged in, so it's fine. So, but as far as like blocking people's work because of that, that is a tough political thing. It's not a technical thing, it's a political thing.
The roadmap.
Yeah.
Those apples that you showed, like the Rails 4 file, are those in the master branch?
Yeah, yeah. It's a very tiny surface, so low risk, and it's so that we can use it from all over the code. That's why it's patched on kernel.
One thing that I didn't understand, you have code for Rails 4 and Rails 5 running at the same time?
Yeah, so what I do is like this, for example, is in one of our models, and when the model's parsed and run, some of the codes will run on a specific version, and some of the code will run on another.
Different versions running on different servers?
Not yet. So like I shouldn't be talking about our deployment infrastructure, but we're not mixing versions at the moment. But when we will, there are some ways that you can tackle how to do this. So we're using Kubernetes, like most people these days, and there are ways that you can actually use traffic to have service weights. So you can have service weights on a service and say that 85% of the traffic goes to Rails 3 pods, 15% to Rails 4 pods. You can do it like that. You can have a header that actually isolates the Rails 4 pods, the experimental ones, to a specific subset of clients. So you don't want to use it for your big clients. You want to start it off with like small ones that only use the service like a couple hundred times a day or something like that. See if it works out for them. There are multiple ways to do that, and we're trialing them all out now. But more specific than that, it's just.
I have a question on that. How you test it out on production? How will you handle the tech debt? So this will provoke some tech damage after you migrate.
Yeah, so part of the reason why it's taking so long is that I'm a bit OCD with that. So if I see quick wins for refactoring and so on, I do them on the spot. But yeah, so we'll end up if we move to Rails 6, we'll end up with this Frankenstein codebase that is Rails 6 on the outside, but it has some Rails 3 and 4 isms in it. That will come with like the evolution of the platform itself. So most of the code will not be moving forward with us. So it's going to be totally replaced by something else. But until it does, it will be just frozen in this Frankenstein kind of state, and then taken out when we write enough microservices to finally kill it.
Go ahead. Okay, so first question is, you started the first example that you showed that there was two attributes, equal attributes in the database, one pending and one status.
Mm-hmm.
Only you didn't handle that. You just the to handle next or something like that.
I did handle it.
So,
yeah.
So I'm asking this because that will constrain the way that they're using the same code in production.
Yeah. So part of the upgrade code is like the upgrade code is not 100% drop in. So that's why before we merged it in, we had this trial period here during the night, me and someone else running some Rails 4 pods, some Rails 5 pods, and seeing if everything's okay, cool. Because yeah, some of the changes are not simple if-elses. Some of them were like, okay, this is pretty bad, let's fix it now.
Okay, so you need to migrate with the third branch and then dig it back.
Yeah, so the code goes out into a normal release. It's dormant, but some parts of it, there are data migrations, stuff like that. Yeah.
So the second question would be, so you're only when handling this?
Yeah, I have part-time help from other people.
Okay, yeah, because that would be my main concern if you go on a campaign or you campaign for sending or a replay bus, nobody will land there.
Yeah, this is one of the reasons I volunteered for this, job security. No, but there are some other people that are in the loop. Most of the changes are kind of like simple. When they introduce some other changes in behavior of the code, I always comment it, link to the merge request notes, always to make sure that one of the problems for the upgrade was that this wasn't done in the past, right? And I just want to make sure that moving forward, we have a different approach to this. Part of that is this upgrade process.
Last question from my side is, I'm guessing that most of your time is creating tests because trying some changes, or not?
Mostly running builds, yeah. My laptop's very hot most of the time, yes.
Just one question from my side. I'm curious, how many gems did you actually have to design? Because they were just not manageable. Like you couldn't really upgrade because of those gems. Let's say like you had to do something with that, and we didn't find a solution.
Right now, there's only one case of that, and it was paper trail. So paper trail, if you look at the history timeline for paper trail, there's version 4, 4.1, 5, 6, 7, 8, 9. So they broke their API entirely between versions, and the old version doesn't work on Rails 5 anymore. And because the code is a bit shady, we're probably just going to replace paper trail with our own thing that does like 20% of what paper trail does, but it works for us. Other than that, it was only actually those two gems. One of them has a replacement written by someone else, and the other one, I wrote a replacement. So out of those hundreds, there's only one problem, which is pretty cool.
Yeah,
Maybe we were lucky.
I'll expect more.
Yeah, me too. So that was my fear. And we also have some custom gems made by us, but they work pretty well on all versions of Rails. So that was pretty good too. Yeah.
I've done a couple of migrations before, and a lot more challenging.
Yeah.
You mentioned that 15% of your components are using Rails 5, right?
Yeah.
You also mentioned that you're planning to go from Rails 4 to 6 directly. Yeah.
Maybe, yeah. We'll see how feasible that is. Yeah.
So maybe you're not going creating the other components to Rails 5.
Yeah, when we move to a version, it has to be all components, yeah. So usually you also you change from Rails 3.2 to 4 to 4.1 to 4.2, so you get all the deprecation warnings between versions and so on. I didn't do that because I knew most of the deprecation version errors and so on already, so I moved straight from 3.2 to 4.2, and yeah. Any other questions? Hey.
So the fact that you have like stuff running against the Rails engine, that you have multiple components, so it does force you to move all the components to perform this at once. Was it really luckily that straightforward to move all the gems from all the Rails engines?
Yeah, so our core is not really a Rails engine, it's a gem. So we could, in theory, have a version of the gem for Rails 3 and require a second version for Rails 4. But luckily, our approach to the domain logic is that most of the work is done in core, and the other apps just accept data, work with it a bit, and change it back. So most of the storage concerns, actually all of the storage concerns are on core. So the other systems are kind of like auxiliary, and their logic isn't too worrisome. So mostly the biggest issue was with our API, because the gem that actually generates the JSON changed somewhat between a version that supported Rails 3 and one that supports Rails 4. So that was like a puzzle for 2 weeks, but eventually it was fixed with one line of code that I'm not going to share because it's super embarrassing. So that was the only issue. But most of the other systems are just adapters, kind of, and core holds all of the keys.
There's a follow-up question. Like, can you give me any ballpark idea of like the amount of code involved in this? Like, I mean, like, have any idea? So how long have you been doing this?
since May. So we have over 150,000 lines of Ruby, over 2 million lines of JavaScript, because we live in a world of dependencies, and a bunch of YAML too. But this, so the first build of core on Rails 4 took 4 weeks. And that was mostly nailing down the deployment, how to test it on CI, with Jenkins back then, the env thing, and all of that. Mostly like core related work, it was like 2.5 weeks. The other ones were more problematic because the other ones have more gems to handle JSON or XML or stuff like that. There is more core is more just storage and validations, stuff like that.
The last question. So just with regard to the Rails, just talking about the upgrades, they being painful. The part of it is not straightforward.
So
from a Ruby perspective, I have to most of it's not easy.
yeah, so the Ruby version upgrade, there was only one problem. I think the only problem that I had was a deprecation on the usage of big decimal, because big decimal was changed in 2.5 or 2.6, and I had to update Shuda matchers to not have the warning, because it was still working, but I hate deprecation warnings. And actually, there's a cool setting for our spec to treat deprecation errors as deprecation warnings as errors and to fail the build. So, for example, there's if you still use the should syntax, it's actually deprecated. I set it to fail the build to change all instances of should syntax to expect syntax, which was pretty simple. But that's going to help you because you don't want to have multiple deprecations going forward to 4 and 5.
So I think we're going to do a short break before the next talk. And if you have any questions,
Yep.
Thank you very much.